Hello and welcome to the AMC-Tec video series. Have you ever wondered how to determine the band gap of a semiconductor thin film using UV visible spectroscopy? In this video, I'll show you a simple and accurate method using real transmittance data. In this demonstration, I'll use transmittance data obtained from a cadmium sulfide thin film deposited on a fluorine-doped tin oxide glass substrate. I've already prepared an Excel sheet with all the necessary calculations, and you can download it from the video description. The sheet includes both the wavelength and transmittance data. First, copy the wavelength and transmittance data. I'll plot the data using OriginLab software. If you don't have the software, just drop your email in the comments section and I'll share it with you. Open a blank workbook in OriginLab and paste the data. Add the corresponding names and units. You may want to rename the workbook for clarity. Select the columns of data and plot a line graph. The absorption edge should be visible around 500 nanometers. In this case, we expect the band gap of cadmium sulfide to be around 2.4 electron volts. If you don't know the band gap of your material, the absorption edge can give you a rough estimate. Use the data reader or annotation tool to find the wavelength at the middle of the absorption edge. For this sample, it's 507 nanometers. Now you can calculate the energy of the absorbed photons using this equation. Now open a new workbook in OriginLab for the Tauc plot. Go back to the Excel sheet and verify how the required values are calculated. Be sure to input the correct thickness of the thin film sample. I'll explain the last two columns in the next video. Copy the data from the two columns in the Excel sheet and paste it into the new workbook. Add the corresponding column names. Select the data and plot a line graph. We already know that the band gap should be around 2.4 electron volts, so we can zoom in on that region. The trick I used for this was the limitation of the software in making perfect curvatures in this S-shaped region. Check carefully these two straight lines. I need to choose data points between those lines for the linear fitting. Still, there are many data points in that region, so I'll zoom in on the region a bit. Again, you can see another two straight lines. I'll choose data points for linear fitting from somewhere between the middle of those lines. If you zoom further, you may lose those lines. To perform the linear fitting, go to Analysis, Fitting, Linear Fit, Open Dialog. Then select the data range from the graph. Start by selecting the middle of the straight lines and reduce the number of points as necessary. Ideally, you want about 5 to 10 data points. Too few points will increase the error, and too many points outside the linear region will change the slope. Go to the Find XY tab and enable the Find X from Y function. To visualize and extend the fitted line to the x-axis for publication, go to the Fitted Curves Plot tab and set X data type to Use Input Data Range Plex Intercept plus Margin. Set the margin value to 0. Click OK. The fit parameters will now appear in a small table. By clicking Yes on the prompt to switch to the sheet and selecting OK, you'll see the full fit details. Go to the Fit Linear Find X from Y1 tab and enter 00 for the Y value. This gives you the x-intercept, which is the band gap of the sample. Copy the band gap value and paste it into the Excel sheet for future reference. You can copy the graph if necessary. Also, you can do some modifications for the publication purposes. If you have any questions, drop them in the comment section below. If you found this video helpful, give it a thumbs up, and don't forget to subscribe to the AMC-Tec YouTube channel for more tutorials. Thanks for watching, and I'll see you in the next video.